Everyone, today in this video we'll be discussing the third module of design and analysis of algorithm, and here we have the greedy method. Suppose that I have a chain here, like here I have 1 and 2, and further extending I have 3, 4, and here I have 5 and 6. Okay, so what does the greedy algorithm say? In each level you have to choose the most optimal solution. In this 2 is greater, so I'll choose that. Then in the next level, what is the most optimal? 6. So in that way we will be keeping on choosing in each levels. Okay, so that's the greedy method. Okay, the first application of a greedy method is in coin change problem. Suppose that in a market you go and you buy some products and the amount is total 30. So what all coins you can give to the customer by using least amount of coins? First you will see which is most closest to 30. 25, you will give 25 and the remaining is 5. Then you will see which is most close to 5. We have a 5 coin here, so here by 2 coins we can do the transaction. Okay, so that's the coin change problem. The second application is knapsack problem. Consider a container here which can have 20 kg at max. Okay, and we have got three colors here: red, green and blue. Okay, these are the weights. 18 kg of red we have, and 15 kg of green and 10 kg of blue. These are the profits for each kg. Okay, see here, for 18 kg we have $25. For 15 kg if we sell, we have $24, and for 10 kg if we sell, we have $15. So what we have to do is we have to find out in 20 kg what all colors in how much proportion we can fill, so that the profit will be maximum. For that, what we'll be doing is we'll be finding out what is 1 kg profit of this. That means 25 by 18 will give me 1.38. For 1 kg of selling red, I'll get $1.38. Similarly, for green it is 24 by 15, which is 1.6. So for 1 kg of green if I sell, I'll get $1.6, and for this it is $1.5. So what I'll be doing is I'll be selecting the maximum profit among these three, which is 1.6 here. I'll be filling 15 kg of green first, because that's the maximum profit, and I'll get $24. Okay, and after that, how many is remaining here? From 20 I have filled 15, so it is 5 remaining. Okay, so then the second largest is this one, 1.5. so I'll be filling 5 kg of blue. For 10 kg of blue it is 15. For 5 kg it will be 15 by 2, that much profit, 7.5. So the total profit will be 24 plus 7.5, which is 31.5. So this is the maximum amount of profit which I can get by filling this bucket. Okay, let's quickly go to the algorithm. Here we have two arrays, P and W. P and W will store the profit and the weights. Okay, so in our case the profits are, the P array will have these three elements and the W array will have these three elements. Okay, and what we'll be doing is we'll be arranging the array in such a form that Pi by Wi is greater than or equal to Pi plus 1 by Wi plus 1. That means the greatest profits ratio will be placed in the first position, then second position here, then third position. Okay, in this order the array will be having the elements. Okay, now after that, what we'll be doing, we'll be iterating each of these, and in each case I will be subtracting u which is 20 in our case, means total capacity, minus W of I, so that weight will be subtracted from the most profit element. After that, the next profit element will be subtracted in the second iteration when I becomes 2. Like that till this gets over, means all the weights are finished, means u becomes 0. We'll be iterating, and after that by using the order which we got here, we'll be calculating the corresponding profits. Okay, the next one is job sequencing with deadlines. In this, we'll have a set of jobs to be performed here, and the profits which we get from here, and within which deadlines we should perform. Okay, now this is arranged in the descending order, means most profit is placed here, the least profit is placed here. What we have to do, we have got the time limit from 0 to 4. Now suppose that this is not there initially, we have empty slots here. Okay, so if the deadlines are of 1 hour, from 0 to 1 hour I have an empty slot here, from 1 to 2 hour, from 2 to 3 hour, and from 3 to 4 hour. Now what I will be doing is I should get the most profit, right? So I'll be starting from the job 1. This is giving me the most profit, and what is its deadline? It should be completed within 3 hours. Okay, so if it's to be completed within 3 hours, I can place it in 2 to 3 hour last slot. Okay, J1. Always you have to place in how much last you can. Okay, then the J2. J2 is the next profit, which is 30, and we can finish it within 4 hours. Okay, so I can place it in the last slot J2. Okay, so you have to see how much last you can. I can place here also, but the rule is to place at the last. Okay, to give the remaining jobs the opportunity to if they have lower deadlines. Okay, so coming to the J3, we have the fourth deadline, means within 4 hours we have to complete. So 4 is already filled, 3 is also filled, and we have remaining here 2, so J3 will be placed here. Okay, and the next one J4, you have to complete within 2, means 1 or 2. This is empty, so I can place here 20. Okay, so this is what here, J4, this one is placed here, J3, J1 and J2. Okay, in this way I can get the maximum profit, which is 110. The next topic is minimum cost spanning trees. What's a spanning tree? In spanning tree, all vertices of the graph should be included and connected. Okay, so initially we'll be given with a graph here. Let's discuss the first one, which is Prim's algorithm. In this, remember this code, smallest connected weights. Okay, now let's see this graph here. In this graph, we have the weights here and the nodes here. Okay, so when we create a tree, see trees like this, it won't have any cycles. Okay, this will not be there, and we have to include all these vertices present here and find out the minimum cost. Okay, means we have to find out the tree in such a way that the addition of all these costs which we make here should be minimum. Okay, so for that, the Prim's algorithm says that choose the minimum cost. Which is the minimum cost among this? It's 10, right? So choose this and make this node and branch here. Okay, so these two will be made here. Next, this is connected to 28 and this is connected to 25. Which is the least? 25 is the least. Make a connection here and erase this connection. Okay, here the connection will not be there. Okay, next, after that we have to choose the, from 5 we have 24, then 22, and from 1 we have 28. Which is the least? It's 22. So I'll make a graph from here, and then next, then we have 18 and 12, 24 and 28. Which is the least? 12. So at each iteration what we'll be doing is we'll be going on with the least elements. Okay, after that we have the options 18, 16, 28. Okay, we don't have 14 because we did not reach till 2 or 7. Okay, so we have to choose between 18, 16 or 28. 16 is the least, so I'll go on with the 16, and after that when we reach 2 we have 14 and 28 and 18. Which is the least? 14. So once we have selected all the nodes, see 1 was selected, 6 is selected, 5, 4, 3, 2 and 7, all the nodes are selected, so we'll stop the process there, and what we'll have is the minimum cost spanning tree. Okay, so this is the tree using Prim's algorithm. Okay, so the total cost will be the cost present at each branch, you add it and you will get the minimum cost spanning tree. Okay, the next one is Kruskal's algorithm. In this we have to select the smallest acyclic weights. Okay, so let's see what it is. This is the same graph as the previous one. This is nothing here, this is the normal branch here. Okay, so we'll be using the Kruskal's algorithm. What it says is choose the minimum point, which is 10 here. Okay, you have choose this branch here and selected the node 6 and 1. Then choose the second smallest among all this, which is 12. Okay, you have to just select the next smallest, and next one is 14, so I'll be selecting 14 here, 7 and 2. Then the next smallest is 16, so we'll be selecting this, and after that it's 18. We can't select 18 because if we select 18, see here a cycle is forming, right? So that we have to avoid. Okay, so we can't select 18, and the next to 18 is 22, and we can select 22 because it does not form any cycle, and after 22 it is 24. If we select 24, it will form a cycle here. We can't select 24, so we'll move on with the next one, which is 25. Okay, when we select 25, we'll be finished with all the nodes, so we'll not look for 28. See, 1 is selected, 6, 5 and 4 and 3, 2 and 7 all are selected, so we'll stop at that point and draw the graph here. Okay, this is the same graph which we will get by the previous algorithm also, and the cost will also be the same. Okay, let's move on to the next one, which is Dijksrta's algorithm. This is a bit hard one, so please pay attention. See here, initially what we have to do, we'll be given with this graph. Write down the nodes here, 1, 2, 3, 4, 5, 6. Okay, so make a table like this and write down all the nodes here. Okay, till from 1 to 6. The source node and the destination nodes are the first and the last one. Okay, this is the source node, this is the destination node. Okay, in Dijksrta's algorithm, what we are finding is from the source node, from 1, what is the shortest path to 2, what is the shortest path to 3, the shortest path to 4, the shortest path to 5, the shortest path to 6. Okay, since there are multiple paths, suppose that for reaching from 1 to 4 I have many paths here, right? See, this one, this one, this one, or like this, or like this. So which is the shortest path? That we are finding using Dijksrta's algorithm. Okay, so first you have to write down all the nodes here, and then write down the weights. These are the weights given. Suppose from 1 to 2 the weight is 2, from 1 to 3 the weight is 4, from 2 to 4 the weight is 7. Okay, in that way, and the directions are also given 1 to 2. it's not 2 to 1. Okay, that's different. So here it is 1 to 3 and not 3 to 1. Okay, so now we have written all these nodes here from 1 to 6, and now we'll be filling the next table, next row. Okay, in next row what we'll be doing, see here 1 is connected to 2 and 3. Okay, for 4, 5 and 6 it's not connected. Whenever it's not connected, we'll be writing infinity below it. Okay, so the weight from 1 to 4 is infinity, from 1 to 5 is also infinity, 1 to 6 is also infinity, and the nodes which are connected, which are 2 and 3, that respective weights will write 2 and 4. Okay, for 2 it is 2 and for 3 it is 4. Okay, after that we have to move on to the next step. Choose the minimum among all of these. What's the minimum number among all of these? 2 is the least number, so circle it, and after that 2 is corresponding to the node 2, right here the node, okay, which is 2. Okay, then after that see from 2 which is connected, 4 is connected and 3 is connected. Okay, so write down the weights of the 7 and 1, but before that we have to see which it is not connected. It's not connected to 5 and not connected to 6. So in below, see first and second is done, and here we'll be writing infinity below it. Okay, 2 is not connected to 5 and not connected to 6 also, so we'll be writing infinity here, and after that these 3 are connected. From 2 to 2 it is same only the previous one, and from 2 to 3 and 2 to 4, observe here carefully. From 2 to 3, what is the weight? 1. But we have to see from the source node. Source node is starting from here. From here if we go 2 and 1, the total weight will be 2 plus 1, which is 3. But initially from 1 to 3 we directly had 4. Okay, from 2 if we pass we will get 3, from 1 if we pass directly we will get 4. Which is the shorter path? This one is the shorter one, right? So we'll be cutting 4 here, which was directly initially, and instead of that we will write the weight of this path. Okay, in this path it's 3, so I'll write here 3, and same case with the 4 also. 2 is connected to 4 with a weight 7. From 1 if I travel through 2, I'll get 2 plus 7. Okay, 2 plus 7 is 9. Initially 1 had no connection with 4, so the weight was infinity here. Now I got the weight here as 9. Okay, so I'll be writing 9 here. Okay, understood the first two? The same thing we'll be doing for the rest also. See here, in the third one, choose the least among all of these. You have to not select 2 because it's already selected. Then the remaining ones 3, 9, infinity, infinity. The least one is 3. 3 is corresponding to which node? 3, right? So write here the node which is 3, and then we'll be filling the next column. Now see here, 3 is connected to which all nodes? Only it's connected to 5. Okay, so we'll be only concerning about 5, and rest of the values of 4 and 6 will be copying from the upper table. Okay, for 4 and 6 we'll be copying from the upper table, and these are the previous values. This will be the same, so only we are concerned about 5. So see here, 3 is connected to 5 with a weight of 3. Okay, so see here, 3 is connected with 5 with a weight of 3, but we have to look from the starting point, from 1. From 1 the shortest path was this, which had the weight 3, and this is the path from 3. So from 1 to 5 I can pass through this shortest path, then the shortest path is this one. So 3 plus 3, which is 6. Okay, so I'll be writing here 6. Alright, from 3 to 5 this is the shortest path, and from here I have weight 3, so from 1 to 5 the shortest path will be of weight 6. Okay, then I will be choosing the least among all of these. Okay, these two are selected. From 9, 6 and infinity, the least one is 6. So 6 is corresponding to which node? 5, right? So I'll be writing here 5, and after that I'll be doing the same thing for 5 also. See here, 5 is connected to 4 and 6. Okay, so rest of the things I'll be copying first. See here, 2 and 3 will be same here, and 5 will be having the same value here. Now the only two connections are 4 and 6. We'll be seeing for 4 and 6 the shortest path. Okay, initially 4 had this connection, right? From 1 to 4 the connection was 2 plus 7, which was 9. Now through 5 what we have? 2 here. Okay, so the least shortest path is 2, 1, 3, till 2, 1, 3 it is 6. 6 plus 2. If I pass through 5 I'll get 6 plus 2, which is 8. This is the shorter path, right, than this one. Okay, so what I'll be considering is, instead of 9 I'll be cutting here. From 5 to 4 the shortest path will be 8. Okay, then we'll be seeing for 6. See, from 5 6 is connected directly with a weight 5. Okay, till 5 it is the weight is 6 and from here I have 5, so total weight is 11. Okay, since it was initially infinity, no connection was there, I got a shortest path now through 5, which is 11. Okay, so I'll be writing here 11 and moving on to the next step. In next step I'll be choosing the least among these, which are already done. The circled ones are already done. Okay, this we did in the previous case, and now we have only 8 and 11. The least one is 8, so I'll circle 8, and 8 is corresponding to which node? See, 8 is corresponding to 4th node, right? So I'll be writing here 4, and then I'll be filling the last row. Okay, in last row only we have to only we are concerned about the last one. Okay, whether we'll get a path through 4 which is shorter than the path through 5. I mean, see here, if I start from here, it's connected to the last one, which is 6 by 1. Okay, and 4 till 4, what is the shortest path? This one was the shortest path with a weight 8. Okay, till here I'll get the weight 8, then passing through here I'll get plus 1, which is 9, right? So 9 is shorter than this path, this one. Through 5 it was 11, through 4 it is 9. So this one is shorter, so I'll be cutting here 11 and writing 9. So at the last step we got all the nodes from 1 with the shortest path. Okay, so this is the Dijkstra algorithm. Coming to Huffman trees and codes, the question paper will be like this. The question will be given in this form. The table will have the letters at the top and the probabilities or frequencies at the bottom row. What we have to do is we have to select the least 2 frequencies. First arrange them in increasing order. Okay, so the least one will be placed first, which is B. Then the next least one is 0.15. Either place this one or this one, that's your wish. So D will be here, then space will be here, both with the probabilities 0.15. Then the next then the next list is C, which is 0.2, then A. Okay, 0.4. After doing this, you have to select the least 2, which is B and D. Make a group out of it and add the values. See here, if I write here B and D and make a group here as x1, then I'll get the sum as 0.1 plus 0.15, that is 0.25. Okay, then we'll not be considering B and D, instead we'll be considering from x1. So we have 4 elements now, x1, space, C and A. Okay, now what's the least 2 in all of these 4 elements? The least 2 is 0.15 and 0.2. Take it separate and make a group. Okay, the least one will be placed in the left, and the more one will be placed in the right. Okay, make a group and add these values, you will get 0.35. Then we have here 0.25 from the previous one and A, which is 0.4, which is the least 2, this one and this one, right? So place 0.25 first and 0.35 second and add these values, you will get 0.6 and 0.4 here. A is least, so place A at the left and 0.6, which is x3, at the right. Then add these values, finally you have to get 1. Okay, 1 because all the sum of probabilities because the sum of the probabilities will be always 1. Okay, and that was the last step here, and after that we'll be just filling the left branches with zeros. This is the left branch, 0 0 0 1 1 1 1 and here 0. Okay, after that we have to write the code for each of the alphabets are present here, A, B, D, space and C. Now the code, how you will write, start from the root node here. To reach A you have to pass through the branch 0, right? So A will be 0. To reach B, what's the code? 1 0 0. So B will be 1 0 0. In that way you will write all these codes from starting from the root node till the destination node. Write all these codes here separately. Now you can be asked 2 questions in the exam. First one is to encode or decode. If they ask for encode, you have to write down the codes for each of these alphabets which they give. Suppose that A, B, A. Okay, what's the code? For A it is 0, so write here 0. For B it is 1 0 0. Then for A it is 0. So like that you will complete the whole code which they have given. Okay, after that they can even ask you to decode. So in that case, what you have to do, select the first 3, write B. Select the next one, which is A. Then select the next one, which is 0, write A. Then the next 3, D. Like that you have to compare the code with these numbers. Okay, and by using that you will get the code here. And this is all about the Huffman's trees and codes. Coming to heaps and heap sort, 2 rules you have to remember. First rule is the heap is the tree is called as a heap only when the elements are filled from right. Okay, so this is not a heap because 2 is filled before the left one was initialized. Okay, so that's not a heap. and here it's not a heap because the parent node, see, parent node should always be greater than the children node. In this case 5 is present as parent node and 6 is present as children node. 6 is greater than 5, which is not possible. Always the parent node should be greater. After getting to know about the two rules, how we will represent the graph in the form of array. In heap sort, we will be starting the array from 1. We will be leaving this space empty, and how we will be filling is we will be starting from 10. Okay, 10 will be filled first, then from here 8 and 7, then 5, 2, 1, 6, then 3, 5 and 1. In that way we will be filling the whole code. And which are the leaf nodes here? The leaf nodes are 1, 6, 3, 5, 1. So how the way to identify the leaf nodes in the array is divide the array by 2. So the half one will be the inner nodes and the rest half will be the leaf nodes. Okay, there are two ways to construct the heap. The first one is bottom up heap construction and the second one is top to down. Let's see the first one. You will be given with this heap here. What you have to do is you have to start from the bottom. Select the least one here, which is start from the right here, 8 and 7. Is this the correct position of 8? No, because parent node should be greater, right? So what we will be doing is a simple step of exchanging 7 and 8. Then next check these two, 9 and 5. It's correct. Go for 6 and 9. This is also correct. Then reach up. In the next level, what we have is 9 and 8. Both are greater than 2. That should not be the case. So select the greater one, which is 9, and place here, and then 2 will come here. Okay, so this is correct here and this is also correct. But since 2 came here, we have to check for the these two also. So while checking this, we observe that 2 is smaller than 6 and 5. Select the greater one, which is 6, and place here, and this will form the correct heap tree. Okay, in case we have to insert a new key or delete the root key, we will be using top to down heap construction. Okay, so in this suppose that this is the tree which is given to us, and we have to insert the new element 10. So we'll insert from here 10. Then we'll be doing the same thing which we done in the previous case. We'll be checking if 10 is less than 8. It's not, so we'll be exchanging it, and again we'll be checking with 9. Then it's then after exchanging we'll get here, we'll get the correct position of the new element. Okay, this was for the insertion. And in case of deletion, we have to delete the root node, which is 9. To delete the root node, what we'll be doing is we'll be exchanging the root node with the last leaf node. Okay, so 9 will come here and 1 will come here. Then we'll be removing 9 from here. Okay, after removing 9, we'll set the correct position of 1, which is we'll be comparing with 8 and 6. In 8 and 6, 1 is smaller, so select the greater one and place here. Okay, so when we do that, we'll get here 8. Okay, and here it will be 1, here it will be 6, and here it will be 2 and 5. After that, we'll be again checking is 1 smaller than 2 or 2 and 5. Yes, it's smaller, so we have to exchange it. And while exchanging, we'll select the greater one, which is 5, and place in the place of 1. After we do that, we'll get here 5, and 2 and 1 will be here only. Okay, so this for the deletion of the root node. Coming to heap sort, we'll be performing the two operations. First one is heap construction and maximum deletions. Okay, so as you observed in the previous case, to delete the new element, see here, the maximum element will be placed at the top, right? This is the maximum element. So to sort the array, what we'll do is we'll be sorting in the descending order. Means this is the maximum element. So what we'll be doing is this same step we'll do and delete the root node. So 9 will come here. In the next iteration, we have 8 here. We'll do the same task with 8 also. So we'll be exchanging 8 with 1 here, and then we'll be performing the same operations here, and then delete 8. Like that, the next highest element will come here, we'll delete that. Okay, so in that way we'll be doing all these iterations, and we'll get a sorted array here. Okay, so see, these are the steps here. These are the steps. First we'll be making the heap, we'll be making the tree in a form of a heap. Okay, that means we'll be using the bottom up approach. If the given tree is not in a heap, we'll be making the addition, we'll be making the modifications which are required, and finally when we get the heap tree here, we'll be deleting the root node. Okay, that's the maximum element by this algorithm. Okay, after we get a heap here, we'll be deleting the maximum element. Okay, so that's it. We'll be using the bottom up approach to create a heap, and after that we get a after we get a heap here, we'll be using the maximum element deletion. Okay, means the root node will be deleted in each iteration, and we'll be selecting those elements which are deleted here and storing it in the form of array. Okay, so the way in which we store will be in decreasing order, and this is the algorithm for heap sort. Okay.